So I'm going to touch a little bit on how we got to this R32 product range. So we're going to go through a little bit of the F-gas laws and legislation and the way we see it. So we've got the HFC phase down, I'm sure you're all aware of that. The information gathered from the market between 2009 and 2012 converted into tonnes of CO2 equivalents, and from the 1st of January 2015 we started what was the phase down or the F-gas regulations all the way to 2030. Now what we see is in 2018, so a little over 7 or 8 months time, we get the first big impact of those F-gas regulations, where we lose 37% of the overall global warming potential of refrigerant into the market. And by the time we get to 2030, we've got to get that down to 79%. So you can see there's going to be a rapid phase down, especially refrigerants with high GWP. And as Donald said, we're starting to see a little bit of impact and movement in the market, and I'll touch a little bit on that later. So what are the key bits of the F-gas regulations? The bottom bit, the light blue, they really are there to assist the contractor and end user. So contractors need to be trained, they need to be certified. You've got to label, report and recover the refrigerant properly and dispose of it if necessary. And then there's the containment measure. So if there's a leak, contractors have got the ability to repair. And same for the end user. They discover a leak in their building, they have a little time limit to get that repair done. At the top half, that is where really as a manufacturer we come in, because we use HFCs in our equipment. So we look at different sectors, we look at what new refrigerants are going to come in and where they're going to fit. And perhaps even consultants get affected by this, because anything that's new in the industry, they're designing buildings 2, 3, even 4 years ahead of time. They need to know what's coming up, they need to know what technology is going to, and again, they need to know what refrigerant is going to be there so they can design their buildings. So I know Donald's touched on this a little bit, and I don't want to bore you too much, but as he said, the history of refrigerant in our industry, when we used HCFCs, we used R32. And as Donald said, it contained chlorine, responsible for making that great big hole in the ozone layer that we got reported in the late 80s and early 90s. Now, my understanding is, because of the actions we've taken, the ozone layers actually started to repair itself. And they reckon by about 2050, that will have fully recovered. So that's down to the actions we've already taken. From the Montreal Protocol, the R22 phase out, 2004 we banned it in new equipment, so we stopped selling R22 back then. In 2010 it was banned as a virgin gas altogether, and by the end of 2014, beginning of 2015, it was phased out in all forms, be that reclaimed or recycled. In between time, we looked at HFCs, or F-gas refrigerants. There was a few around, so R134A, used a lot in the motor industry or for large chillers. R404A, which was predominantly used for refrigeration. 410A, which was around at the time, but not widely used. And the choice, the in-choice refrigerant as initial R22 replacement was R407C. From 407C, we moved across to 410A. It was around, 407C was around for about 6 years. So it started around about 2000, and we started to see the phase out in about 2006. And what R410A brought us to the market was the first of our power inverter range. So this is where we used inverter technology into smaller systems. So whereas with R407 we were getting COPs of mid-2s, late 2s, we then start to see COPs in the high 3s, early 4s. So it gave us a great big influence in the amount of energy that could be saved using heat pumps and inverter technology. However, all these phase downs and previous F-gas laws have had or not had the desired effect. Hence, we've got this new EU target, a total GWP reduction of 79% by 2030.